Imagine you're back in school and your teacher reviews your answers to tough questions. If there's a mistake, it's pointed out and with some guidance you fix it. Great! In programming, checked exceptions work similarly. They help you ensure your code is error-free by catching issues early on. In this video, you'll learn how to handle checked exceptions in Java, making your code more robust and reliable. Another way to think about exception handling is to think of it like a game of basketball. When a player catches the ball but can't shoot, they pass it to another player who's better positioned. Similarly, when an exception is caught in your code, it can be passed on to another method for handling. Just as the ball moves to the player most likely to score, exceptions move to where they can be best handled. Checked exceptions are a safety net that ensures your code can handle unforeseen issues, such as missing files or database connection errors. By now, you've encountered various exceptions in a variety of scenarios, like the I/O exception or the class not found exception. Let's dive into how to manage these exceptions using the try-catch mechanism to ensure your applications run smoothly. First, let's explore how to handle the class not found exception, which occurs when you try to load a class that isn't in the class path. Here, a red underline indicates where the exception occurs in the code. To handle it, surround the line of code in a try block as try followed by an open curly brace, the line of code, and then a closed curly brace. Next, you need to place a catch block below it with code to handle the exception. So, type catch, and then open a pair of parentheses to pass the parameter, and then open a pair of curly braces. You know by now that the catch block should define a parameter, which is the exception type it handles. In this case, it's a class not found exception. So, specify the exception class name within the parentheses and give the reference variable name, which in this case is E. The exception handling code should be placed in the catch block. Simply print out the exception message with a print line statement. Specify e.getMessage. Then run the code. It will print out a message from the catch block specifying the name of the class that was not found. This approach ensures your program handles the error gracefully without crashing. Sometimes, you might want to rethrow an exception to pass it up the call stack. Earlier, you learned the exceptions can propagate from a lower-level method to a higher-level one. For instance, if an exception occurs in method M1 and you don't handle it there, you can rethrow it to method M2, and so on, allowing the exception to be managed at a higher level. When an exception occurs, this call stack is searched for an exception handler, starting from the method where the exception occurred and proceeds through the call stack in the reverse order in which the methods were called. When a suitable handler is found, the exception object is passed to that handler or the catch block. Despite the usual behavior, if that catch block doesn't want to handle the exception, it can rethrow the exception using the throw keyword. Doing this propagates the exception to a higher level in the call stack. This technique is crucial when you need a more comprehensive approach to exception handling across multiple methods. Let's explore this with a code example. In this code, method 1 is where the class not found exception occurs. It's called within method 1, while method 2 is called within the main method. So the main method lies at a higher level of the call stack. Let's place a try-catch block surrounding the code that causes the exception in method 1. Now, without handling the exception in this catch block, you can rethrow it using the throw keyword. So, type throw and then the exception object E. You also need to declare that method 1 is throwing an unhandled class not found exception using the throws keyword. So, in the method signature, add throws class not found exception. There is a red underline in method 2, when method 1 is called. This is because the exception has been propagated to the next higher level of the call stack, which is method 2. Wrapping exceptions in custom exceptions allows you to provide additional context. For example, if you're handling a class not found exception, you can wrap it in a my custom exception to include more details, like the specific class path or configuration that caused the issue. This technique not only makes debugging easier, but also enhances the clarity of error messages. Let's explore how this works. Create a new class named myCustomException. It should be a subclass of the exception class. So type in extends exception. Define a private string field named additional info. Add a getter method for it. Create a constructor that initializes the field additional info. The constructor should also accept a throwable, which is the original exception object. Invoke the superclass constructor within the constructor by typing in superThrowable. That's it! You got it! That's all it takes to implement your own custom exception class. Now, back to the code that causes a class not found exception. In the catch block, you can type throw my new custom exception. You can pass the exception object E and some additional info into it. Assume you have a connection URL. For example, if you have a database connection link like this, you can pass both the error message and the connection link to your custom error handler, which will call myCustomException. Finally, make sure to indicate that method 1 can trigger this custom error by adding throws myCustomException to the method declaration. By mastering checked exceptions, you are enhancing your code's reliability and making it more resilient to unexpected issues. Rethrowing exceptions helps you manage errors at the right level in your application, while wrapping them in custom exceptions provides richer, more informative error messages. Just like the basketball player passing the ball to the best shooter, you're learning to pass exceptions to where they can be best handled. Use these techniques to build robust, professional-grade applications that stand up to real-world challenges.